So choosing Rust as our main language for the system in the backend was, I would say, the best decision we made in terms of our stack.
Let's discuss the basics. Can you provide an overview of the features in the new software?
Yeah, so the Arculus Fleet Manager consists mainly out of 3 feature domains: the layouter, the simulator, and the operator. In the layouter, we provide the user with a layout editor and a layout manager so that they can basically create their project into the software. The simulator helps to simulate that layout and try to understand the performance of a certain project. And an operator, that's basically then where the fleet manager is handling all the arculus, the robots as we call them, and controls traffic and charge and so on.
What fundamental changes did you apply in creating the new generation of Arculus fleet management software?
The user journey of the product for us was very important, and basically the key frame. We had a fleet manager already in the market in some projects running, and the experience from that, and also considering actually the users which are then using the software, led us to conceptually create a new fleet manager, having in mind that we want to have one tool for the whole user journey from pre-sales to basically operation, so that we can provide a coherent user interface. And perhaps Axel, you have some great insights here.
So basically, the fundamental problem that we had with our previous product is when the user did some change, like moving a driveway around or adding an additional driveway, and then figuring out what is the actual impact on the system. This would take a long time. And now for the new generation of product, our goal was to make this as short as possible. Like, you change something and then you can immediately see the effect, so you can run many iteration cycles in a shorter amount of time, finding the best layout, of course.
And just to add on that, actually I'm among those user groups who greatly benefit from the new piece of software, because in our test area I'm able with the Fleet Manager now to set up a test area or a test project within 30 to 45 minutes, and I don't need development support because they are the experts for other things than just only using the software.
Yeah, this has one of our main development focus on integrating this whole process that Georg introduced into this one solid product, which just works. That's what it's about. It should just work, and you should not need any kind of technical support to be able to use it.
Moving to the technical topics. How does the user interface of the Fleet Manager facilitate ease of use, especially for the various user groups and complex operations?
So the first thing what a user usually does is you have some sort of shop floor. Either you have from a CAD system, like if there is like a new factory build or new factory building build, or you go with the robot and scan the environment so that you get a shop floor, and then you have to place objects on top of it, like driveways, stations and whatnot. And basically this is what the user wants to do, like define the features that there are in the factory, and then we try to make it as easy as possible for the user to basically capture this intent from the user. And then for our internal representation in the Fleet Manager, we need to basically convert this to a data structure that can be used by the robot.
Yeah, one part of this is what is at the core, is supplying the user with, or when the layout, we call it, is validated, which means that we did all the checks. And if they didn't pass, tell the user, oh, you did this wrong, or this is not allowed. But when it passes, it should just work out of the box. There should be no tweaking required for somebody who sets it up to, let's say, ensure that vehicles do not collide or that vehicles do not lock each other in so-called deadlocks. That's one of our main points. then that when the user creates a layout and it validates, then it's ready to go and it doesn't need to do any more to make it functional.
Yeah, and perhaps to add on this, one of the premises we actually laid out what we want to do with that product, especially now during the initial development phase, is to test with the users. Yeah? And this also means now all these journeys Axel has been describing, we basically develop, we test them, we see what works, which is not so well working, and then we are improving that.
How did you decide on the technology stack and architecture for the new fleet manager?
Maybe starting from the back-end side. So this is the part where we do all the complicated algorithms, where we do all the logic and all the communication with vehicles and with other connected systems. There we looked at what's most important to the customers we deploy our project at, and it is that it's reliable and robust. You don't want to be woken up in the night by crash or have the whole shift blocked, the whole work shift at, let's say, some factory or some logistics center, just because the software crashed or just because something in the software played out in a weird way that you didn't expect. So this meant that robust and safety was number one for us. Also performance, because we are also targeting large fleets, not just small projects of a couple of robots, but possibly over 100 vehicles, which we actually already tested in simulation, and it works like a charm. So performance, safety and robustness were important for us. So for the back-end system, we built on top of Rust, which is a really great and emerging language, which focuses exactly on these points. And so this is the foundation for our back-end system.
So for the front end, also of course we're having a web-based front end, which allows us to, on the one hand side, utilize the richness of the web-based front-end ecosystem. On the other hand, it allows us to basically deploy the software on one server and then access it with basically every client. And regarding the specific technology stack, so we went for a combination of Angular, which is the SPA framework provided by Google. And on top of that, we put a 3D engine.
The tech stack which the team choose is able to run on a standard business machine, and this enables me to test and also to verify, and this also gives me the assurance that actually it will run on standard customer computers, which are very important, because our customers, they basically have as many companies, IT regulations, and therefore the technology choice was not only driven by deep and detailed engineering decisions, basically.
Were there any particular tools or frameworks that proved to be pivotal?
Myself, coming from like this world of systems programming, where you use languages like C++, or some people, when you go down to embedded, even C, you have a lot of overhead with your tooling. You need a lot of additional tooling to get it all building, to get it all running. So choosing Rust as our main language for the system in the backend was, I would say, the best decision we made in terms of our tool, of our stack. Because it brings all of this out of the box. We don't need additional tooling for building. We don't need additional tooling for dependency management. It's all part of this one ecosystem, and it's also a really big and more growing ecosystem. So a lot of other components that we're using are already there, which makes our development life much easier.
And perhaps one anecdote out of this, because Rust as a development language was also quite new to the team, right? Yeah. So after the first sprint, basically one of the team members came and said, I think I will never learn this Rust language. It's conceptually, different from what I'm used to, but already 2 or 3 sprints later, this was all gone. It was also very easy, let's say, to onboard the team to a new technology.
What is the role of VDA 5050 in the new software? What benefits does it bring to users?
Yeah, so VDA 5050 is a crucial part in our system because it's a specification that outlines how a fleet management system should communicate with a robot. So it's developed by a lot of big companies together to specify how this should look like. We actually at Arculus are contributing to the further development of the specification, and it helps us in multiple ways. So first of all, it takes some overhead away from us of defining how this communication should look like. We actually, with the new fleet management system, got rid of our legacy communication protocol, which was developed in-house, and replaced it by VDA 5050. So this is one advantage, but also we have the advantage that we have interoperability. Since it developed as an industry standard and it's backed by many other developers of fleet management systems and robots, we can potentially drive all kinds of different robots with our own fleet management system, which provides a lot of flexibility to customers. But also, speaking about our robots, they also support, of course, VDA 5050. So if a customer decides to use a different fleet management system, this would also be fine.
Yeah, I think most important is our legacy system already implemented VDA 5050. So actually we have projects already running where we only provide software and where the robot is coming from other players in the market. And this is of course a field where competition, this buzzword, plays a role, right? You're friends, but you also have competitors in the market. But I think, as you said, it only enables us to learn from the market.
So usually when we are supplying such an automation system, it's not a greenfield project. So we contribute some part of it, and usually we have interfaces to other parts of the factory floor. And even sometimes we have mixed traffic. And of course, if we have our fleet system, our fleet manager with our robots, we can nicely visualize them on a canvas. But sometimes one of our vehicles cannot drive because there is another vehicle from a different vendor, from a different system that fulfills a different role. And of course, we would also like to visualize them to give the user the transparency, why is this particular vehicle not moving? And of course, VDA 5050 helps here because it's a standard communication protocol, and we can also utilize the information from all the other vehicles that are on the factory floor.
Okay, let's talk performance. What strategies were employed to optimize the performance of the new fleet manager, particularly in handling large fleets in complex environments?
This was also one of our central points in developing the fleet management system, that we want to be able to support those massive fleets of more than 100 vehicles. So we took the decision to employ modern algorithms right out of the academic world, which handle those kinds of cases, which on a detailed level work by subdividing your space into smaller regions. And different to our competitors, we are not just checking if where we are driving is free, we are also checking if this could in the future lead to potential lockings where a lot of vehicles suddenly stop moving because they have no more space to go. And so we are one of the only in this industry who are able to do this. So we had to take those algorithms and of course modify them, because the real world is always more complex than the academic world. But so far we're having great success and actually controlled in the simulation a fleet of 150 vehicles on one of those potential layouts.
How does the fleet manager's back-end handle real-time data processing and decision-making?
Yeah, good question. So of course, if you think about a fleet of robots driving around, you don't have a lot of time to tell them what to do, because if they don't get another command, they will just keep standing there, and no orders will be processed, no material will be delivered. So it's important for us to always react as fast as possible. So on the one hand, we have our modern tech stack combined with our algorithms that allow the super fast processing, the super fast decision making. But on the other hand, we have VDA 5050 as the communication protocol. so that we can directly communicate with the robot and send it updates as quick as possible. So this together allows us to react to other changes in real time. This is just from the operational side of commanding robots. Then we also generate a lot of data while driving around, while operating on some kind of setup. And this data can then also be used, for example, in an evaluation phase or while being operational to further monitor what's going on.
And just to add on 2 points, you have to, when you deal with real-time data, right, you have to think of actually what is real-time, and what is the heartbeat of a robot actually, so the data heartbeat of a robot?
Yeah, so it really depends on what kind of data you're looking at. Let's say just for visualization, so that's what Axel is concerned with. The robot sends updates multiple times a second. On other parts of the communication, it's more event-driven. Let's say a robot got the clearance to drive to a certain location. And on its ground, it passes certain waypoints. And when it reaches a waypoint, it will update us to tell us, hey, I reached it. So we can run some more logic and potentially change something or just command it to drive even further.
Yeah, I mean, great input, because this is exactly what I wanted to refer to. You have to create several abstraction layers to deal with the relevant data you actually want to use and want to expose, for instance, to your users as well, right? And having said that, perhaps Axel, you mentioned already the performance of the, let's say, the layout canvas, So this is, so to speak, the digital twin of the site, the warehouse, the factory, on what's going on there. And if we want to display the state of a robot, the state of the battery, where it is moving, the route it is taking, and so on, I think you can iterate on how crucial it actually is to process and then display that data to the user.
I mean, for the user, like if the user gives the robot a manual command, like drive to some location, drive to charging, the user wants to see an immediate feedback. And if you have seen the robot in action, it has to do certain things before it can start driving. Like it has to switch some sensor, it has to release the brakes. If you are close to the robot, you can hear it. But if you're sitting in front of your PC, like every fraction of a second that adds up to the total delay until the user gets some feedback is crucial. So we're talking, let's say, several hundreds of milliseconds, which would be acceptable. But if we're talking several seconds, then the user would already say the system is sluggish or the system is broken. So, I mean, it's nice to have like the UI animated and whatnot, but it's crucial for the trust of the user to the system to exactly tell the user what's going on and also give the user immediate feedback to any user action that he initiated.
Thank you, Georg, Andy, and Axel for sharing your expertise with us all. See you in the next video.